40 years old. I've been working in INC, I mean, instrumentation and control field of study, field of engineering for around 16 years. And I've been just working in different industries such as oil and gas, mine, steel, chemical industry, and some more else. Besides the career that I've just taken, I'm an INC trainer too, referring to the thing that Nick just specified before. I've been training more than 3,500 engineers and technicians all over the world. And there are a lot of, movies and, how can I say that, films, technical films about me, about, working with instruments, valves, and control system on the internet. You can just find it in YouTube or even in uniclass.com. But Uniclass, it's with K, actually, UNIKLASS.com. So you can just, go through that website and find, some more technical movies about me and, the practice of some more things. So let's just put all these things aside and talk about the things that we want to present. One of the most important things or criteria that we need to just put our fingers on is flow measurement. To tell you the truth, this item is one of the most challenging thing in instrumentation. I want to just make it a little bit clear for you why this one is really important or really challenging. When you just compare these measurements, I mean, flow measurement with some more things such as temperature measurement or even pressure measurement, you can find that there are a lot of types and principles of measuring in industry. You cannot imagine this one. We have around 14 types of different, instruments that we can apply for measuring the flow in different industries such as oil and gas, steel, water, mining, and stuff like that. Moreover, when we just come to this part, I mean, flow measurement, you can just find out that there is a kind of link between electrical engineering, I mean, electronic, and even mechanical ones. When I'm talking about mechanical, I'm talking about fluid mechanical. In this case, you have to know some more things about the process, about even the piping too. So that's why it's a little bit complicated or sophisticated, because as an INC engineer, you need to consider a lot of factors, a lot of parameters to design and use the flow measurement instrument. One of the most challenging questions that a lot of engineers and technicians find is that which type of flow measurement is suitable for a case of, measuring the fluid. Sometimes they try to use a differential pressure one, but after that, they find out that, oh, that's a really, bad thing. And unfortunately, they made a mistake. So it was really better if they could have, for example, chosen the Coriolis for that case. So I want to just, give you a picture of flow measurement in this webinar. I just want to just keep all the things, from the basic, because one of the respected participants just mentioned this one, whether this webinar is suitable for him or not. I just want to tell you that, yeah, for sure, certainly it will be useful, because I'm trying to teach you all the things from the basic. And after that, we will just reach to the, how can I say that, a better, level. I cannot tell you that, it's professional level, because it's just a virtual impossibility. For sure, it's a virtual impossibility, because if you want to be an advance in this regard, you need to just spend a huge amount of time working and, how can I say that, designing and studying, for sure, actually, the standards or some handbooks. But for sure, I'm trying to do the best to just teach the most important factors. And for each one, I'm trying to just, give you some examples to clarify this matter for you. So, first of all, I just want to share a paint page for the participants. And I'm going to just teach some, I'm going to just, write something for you in the paint page, because I suppose in this case, maybe it's a little bit more easy, much easier to understand and grasp. So let's just share this paint page. Okay, now it has been sharing. That's nice. Okay. So, okay. I suppose you can just see that. Is that right or not? Let me just do that again. I suppose there's just a problem here. Okay, here we go. It must be share from this part. It's the paint page and share. Okay. So it's about flow measurement. And now I'm just writing something here. Okay, it's flow measurement. So before anything else, I just want to tell you that we have these options to measure the flow based on two different units. The first one is based on the volume, and the second one is based on mass. When I'm talking about volume, for instance, I can say cubic meter per an hour, or even, for example, it can be liter per minute, or things just like that. And when I'm talking about mass, for example, I can say kilogram per an hour. So this is a first item that you need to bear in mind. Which types of flow meter is suitable for measuring these things? I want to just, mention this, one of the most challenging thing, and step by step, you get familiar why it's so complicated and sophisticated. First of all, I just want to tell you, if you want to convert these two units, I mean, these two dimensions to each other, you can just apply the density. I mean, if you just multiply the volumetric flow measurement into density, you can reach to kilogram per an hour. But there's a point here. For some cases, the density will be changed. How? Just imagine about air and gas. For air and gas, when the pressure goes up, unfortunately, the density goes up too. So I just want to tell you that there is a relation. I mean, there's a direct relation between P, pressure, and density. When we just take temperature into consideration, we will find out that when the temperature goes up, the density comes down. So in this regard, there's a reverse relationship between temperature and density. So now just imagine you want to measure the flow of the air or gas in your piping. Unfortunately, we do not have the ideal case in our piping. I mean, step by step, every second, every minute, the pressure or temperature or even both will be changed. So in this case, the density is not fixed. As you know that when we talk about density, we have kilogram per cubic of the meter. We all know that the kilogram, I mean the mass, is always constant and it cannot be changed. So when the density under the circumstances of the changing pressure and temperature changes, so in this case, the volume will be changed. Now, as you can see, when the volume changed here, the flow, I mean the volumetric flow, is going to be changed. So I just want to tell you that in this regard, you cannot be certain and you cannot be sure about the amount that you read on your flow meter. I want to tell you that in this regard, all the things are wrong. So that's why there is a point, or there is an kind of, attempt in industry to change the volumetric flow into the mass. Otherwise, we will find an error. Sometimes this error will be raised a lot up until the time that we will lose a lot of things. How? Just imagine, for example, a company, a gas company, decided to export gas from a country to another one. Now just imagine after a while, I mean, just after 6 months or even after 1 year, when they try to, analyze the cost, they will find a big loss. Maybe, for example, sometimes they will have, some benefit or profit, but it can be joke because for many cases, we will face a lot of loss. So that's why, as I mentioned before, in many kinds of, applications, when we want to export or even import fluid from a point to another one, we try to change the volumetric flow measurement into mass. In this regard, it's just, simple thing. How? Just imagine it's a pipe. Now I have 3 transmitter here. The first one is a flow transmitter. Second one is pressure transmitter. And finally, we have a temperature transmitter. So as a kind of point, please bear in mind that when you want to install a pressure transmitter or temperature transmitter in the line, you must install them after the flow meter, because by using these 2 items, you might change the profile of the fluid. And in this regard, the turbulency that shaped in the pipe will have a really bad effect on your flow meter. Step by step, I will teach you about these things too. So after that, we need a flow computer. To use it, we can just, you mention it or specify it as FY, which is related to flow computing. So there's a flow computer. For this one, I can just, make an example for you. The Flow X model from ABB brand, or even the Summit 8800 from Krone can be found in the market. We can just use it and connect these signals to this flow computer. And with the help of some equation, the density is measured all the time, I mean, permanently, based on the changing of the pressure and temperature. I mean, density always is calculated. And after that, density will be multiplied into the volume flow that these flow meters read or shows. Finally, we will reach to flow based on mass. This one is one of the most important things that I wanted to mention at first. The second point that I want to put my fingers on is Reynolds number. Reynolds number is one of the most important things that you need to have in your mind. First of all, I just want to say that Reynolds number shows or presents the profile of the fluid. Sometimes the fluid is laminar. I mean, it's very close to the linear form. Sometimes the fluid is transit, and sometimes it is turbulent. For each of these cases, we have a Reynolds number. Do not forget this one, that Reynolds number does not have any dimension or unit. It's just a number. So I just want to tell you that Reynolds number is related to many different things. For example, the internal diameter of a pipe. When the pipe uh, is the bigger one, for example, 48 inches, for sure, it's more possible to the fluid becomes turbulent up until that the pipe is just 2 inches. Just imagine sometimes the velocity of the fluid goes up, for example, around 6 or even 7 meter per second in a pipe. For sure, in this case, we will have more or bigger Reynolds number up until that the fluid is just, streams within 1 or even 2 meter per second. So it's so important that which types of flow meter is selected based on Reynolds number. For instance, when we're talking about Coriolis flow meter, I mean mass flow meter, it does not have any relationship with Reynolds number. I mean, it can be used for even turbulent cases or even the fluid in transit form. But sometimes when we're talking about, for example, vortex flow meter has a direct relationship with Reynolds number. For example, vortex flow meter is applicable when the Reynolds number is greater than 10,000. And unfortunately, this flow meter, I mean vortex, cannot be used in the fluid which has less than 10,000. I just want to mention some more things. In vortex flow meters, when the Reynolds number is greater than 20,000, the accuracy of the vortex becomes better. It's around, for example, 0.75%. But when the Reynolds number is between 10,000 and 20,000, the accuracy is around 2%. So I just wanted to clarify this matter. In some cases, I mean, in some instruments, even when Reynolds number becomes greater, everything seems nice. But unfortunately, when Reynolds number is less, maybe the device, I mean, the instrument cannot be used or cannot, measure the flow. So do not forget this matter. For these items, Reynolds number is so important. So you need to have this one. So I just wanted to just draw some examples to clarify this matter. Step by step, we will just talk about some more things about Reynolds number for other flow meters too. Some more things. I just save these pictures, or I mean the paint files for you too. And by the end of the webinar, I will just submit all these webinars to PEA company, and if PEA company wants, they can just send it for you too. So another one that I want to present now is it's related for how we can measure the flow in the pipe. In this case, we have two principles. So I just want to show that it's the ways of flow measurement. We want to talk about the principles. Okay, so the first one is measuring the flow based on differential pressure. So the first one is differential pressure. Now, let me just draw something for you, and then we will talk some more things about this one. So I'm just talking about an orifice. When we're talking about an orifice, for sure, it's just a plate with a hole in the middle of it. So I can just, share some more things for you. You can just, let me just share my screen with you. Okay, this is my screen. And I suppose you can just, this item too, the PowerPoint file. So as you can see here, there's an orifice plate. orifice plate is one of the most important, device or instrument in this industry. I mean, instrumentation industry to measure the flow. For sure, it has a lot of profits. For example, the first one is that it's very cheap. To tell you the truth, I can tell you that it's the cheapest way of the flow measurement. That's why when you just look through an refinery, you will just see that maybe around 50% or even 60% of the instruments for flow is just based on the orifice. But unfortunately, it does not have a really good uncertainty and it does not have a good accuracy too. Moreover, there is one more thing that I just want to say, and it's just related to the differential. Sorry, it's just about the turn down ratio too. So before anything else, I'm just writing turn down ratio. Sometimes it's called that rangeability too. And it's the ability of the interval of the instrument measures the flow. How? It's a kind of relation. It's the maximum. Okay, sorry. It's just the maximum of the measurement divided into the minimum of the measurement. Each instrument has the turn-on ratio. For example, when we are talking about the orifice, we can imagine 3, 2, 1 for the orifice. But when we talk about a variable area flow meter, I mean rotometer, we can have it around 10 to 1. When we are talking about a turbine flow meter, we can just have it around 20 to 1. But when we talk about, for example, an ultrasonic flow meter, it can be even 200 to 1. So what does it show? It shows that when the flow meter can measure around, for example, 300 cubic meter per an hour for case of maximum, it can just, for example, 100 cubic meter for case of the minimum. So that's why it shows the turn-on ratio of 3 to 1. So 300 to 100. In this regard, this flow meter cannot measure 0 to 100. So that's why this part or this interval or this period is called as zero cutoff. Sometimes it's called as zero cutout too. It means that this interval cannot be measured by this one. To tell you the truth, the best part or the best period for measuring this device is just between 100 and 300 because the linearity of the device is just, fixed in this part. So this is one of the most important thing, or I just want to tell you it's in another factor or criteria that you need to have in your mind when you just want to consider or just design a range for your flow meter. You need to have the minimum of the fluid inside of the pipe. You need to have the operational flow and you have the maximum flow in the pipe too. So you need to consider all these parameters, all these data, because all these data must be placed in this range. This is one of the important thing, or how can I say it's one of the challenging thing that I've just faced in different projects for many times. Sometimes when the operator who are working on the side, and we're just call them as foremen, have this complaint that why this flow meter cannot measure this part or this amount. They just try to connect with the boardman in control room and they just ask, okay, so how much do you see or do you find in your HMI, I mean human machine interface? They say, for example, just it's 0. And they get shocked. They say, how is it possible The flow streams right now around 20 cubic meter per hour in the pipe. How is it possible for you? You cannot find anything on your HMI. Sometimes they say that maybe the flow meter has not been calibrated yet, or maybe there is just a problem in the calibration of the flow meter, but it's not true. Why it is not true? Because this flow meter has the capacity, or has the um, opportunity, or how can I say, has this point to measure from 100 to 300. This is just the ability of the flow meter, not more. So you cannot, expect from this flow meter to measure from 0 to 100. I just want to, clarify this matter again for you, that each flow meter has its own turn on ratio, and you need to just, check it out from the manufacturer's catalog. But I just want to tell you that all these things are fixed. You cannot, for example, find a vortex flow meter with, for example, 100 to 1 for case of turn down ratio. Why? Because it's the maximum one is around 50 to 1. So you need to just consider these matter for choosing the elements too. So when we just get back to the orifice, because we were just talking about differential pressure, when you just put it between the pipe, you just have it, for example, this is the pipe, and with the help of the flanges, we can just put this orifice in the pipe. Now, if I just, show the flow direction in this case, it's the simple thing that we can just do. We can just, put two isolating valve on the flanges. And now we can just connect these two tubes into a differential pressure transmitter. As you know that this leg is high pressure and another one is low pressure. Please bear in mind that we just consider this one from the flow direction. I mean, the upstream of the device will be high pressure, and the downstream of the flow element will be low pressure. This is another thing that I just want to show you, that the pressure and the velocity has the reverse direction. This is the velocity. It's just based on the Bernoulli constant, or the Bernoulli equation. When the pressure goes up, for sure the velocity comes down. So this point is the point that we can find more Reynolds number. Here we have just greater Reynolds number. Why? Because in this point we have more velocity. For sure that the pressure has been dropped in this part. So with the help of measuring the differential pressure between these 2 points, we can just find that flow has a equation, or has a equality with K as a kind of fixed constant to the root of the delta P. Delta P is the differential between these 2 points. And in this regard, we can just find what flow is in our pipe. Again, I'm just saving this page for you. This is the second principle that I just want to specify. And it's just based on the velocity. Now, when we have the velocity, or when we can calculate or measure the velocity in the pipe, we can find how much flow is in that line too. How? Flow is equal to A. A is the area, or the cross-section of the pipe. It's multiplied into velocity. So there are a lot of devices that we can use, or we can apply to measure the velocity. For example, one of the most, how can I say that, famous one is turbine. Another one, for example, is vortex flow meter. We have even the magnetic flow meter too. So these are the principles that I just mentioned, and based on these items, we can just find out the flow inside of the pipe. Now, I just want to continue with some more things, and you can find another clip that I myself prepared for you to talk for this webinar. I can find out that you can just see that. So for let me just, stop sharing again and just share this screen again to be sure that whether you can see that or not. Okay, I suppose everything seems well now. So it's about the flow measurement. Now we just want to talk about all these things in the as a kind of briefcase. So this is the first thing that I just mentioned, that we have the first item. It's for the basic one for sure. It's about the differential pressure. As I mentioned before, it's the simplest way and the easiest way. For sure, these items will have a lot of advantages and benefits in an industry too. For example, looking to the size, we have a wide range of size, pipe size that we can use. For these items, even we can just find them from 1 inches of the pipe up to even 120 inches of the pipe. So for sure, we can just find all of them in big range of pipe sizing. Moreover, they do not have any limitation in case of measuring the fluids. They can be used even for liquids. They can be used even for steam and vapors, and even they can use before air and gas. So that's why I can just tell you that it's the easiest way and the simplest, and for sure, actually, it's the most applicable one in different industries such as oil and gas, mining and chemical and steel and stuff like that. These items, as you can see, can be just categorized into different cases. The first one is pitot tube. Recently, I suppose it's around 25 years ago that Emerson Company decided to just, get the pitot tube promoted, and they just made it a little bit better. That's why these days we have a kind of the measuring instrument in industry called as anobar. If you just find this anobar on the internet, you can find that it has been manufactured and produced by Emerson Group. Actually, it's the principle is just based on the pitot tube, and pitot tube is sometimes can or let me just say it at first and then continue my words. Pitot tube can be used even for measuring the velocity on the airplane. It's the most famous and well-known device for measuring the velocity of the air flights too. So for pitot tube, we can find the measuring the velocity at first, and after that, with the help of the equation that I just wrote for you, the amount of flow will be measured. Another one is Venturi tube. For sure, actually, it has a historical background for Venturi tube too. But one of the most problem, or how can I say, a challenging problem related for Venturi is that sometimes it cannot be used for bigger sizes of the pipe. For example, when you just imagine 30 or even 40 inches of the pipe, in this regard, maybe the elements, the flow element becomes very big. Sometimes it's around, for example, maybe, I don't know, 3 meters of the length. Moreover, the way will be really heavy. So, and in this regard, maybe you need to pay hundred thousands of dollars to just fabricate this one. So in this regard, I just want to tell you that the Venturi even can be used for 120 inches. But for sure, when we just want to design, we try to keep the size of this one as small as it can be. Maybe it's just around 10 inches, just like that. But please have this mind that the Venturi is really applicable for case of steam, because when we just compare the venturi with an orifice, you can just find that even the strength of the venturi is much better than the orifice. So that's why it can be used for steam. You know that when we're talking about the steam of the boiler, in the industry, we're just working with the temperature around 230 or sometimes 280 degrees of centigrade. Moreover, in this case, we have the pressure around maybe 40 or even 45 bar. So in these cases, venturi would be really better than orifice. Another one is flow nozzle. For sure, it's really, great things, but it's just only used for case of measuring flow of the gas. Unfortunately, it has its own, cons and disadvantages, because when we just install it in the pipe, unfortunately, we cannot remove it from pipe easily. So that's why, as compared to the orifice would be, preferable. I mean, more preferable as compared to flow nozzle. So flow nozzle has, different models and different, shapes. So that's why it can be categorized into long radius one. It's ISA 1932, and finally the venturi nozzle. It's another type of flow nozzle that can be, mentioned. The orifice, as I said before, is really applicable. For sure, it's the cheapest one. For sure, actually, the maintenance and the operation of this one is much easier as compared to the others. And just imagine, for example, you put the orifice and install the orifice inside of the pipe, maybe, after 2 years or 3 years later, you need to just change it in because, it maybe it is eroded, or, for example, some parts of it was under the exposure of the corrosion or even erosion. So it's not a really big deal, because maybe maximum you can just find it with 200 euros. It's the maximum price that you can find it for these smaller the plates. Another thing that I just want to show you, that, and this one is really important. Please just pay attention to this part. It's a kind of question that a lot of participants and a lot of engineers and technicians ask me all the time, that whether it's possible to install the flow meter in the vertical line or not. For sure, you can install all these flow meters in vertical line. There is no exception. I'm just saying this one again. There is no exception for flow meters for installing in the vertical line. But there's just a point. If the flow direction of the liquid, please pay attention. If the flow direction of the liquid is from bottom to top, you can have this one. And for case of gas services, when the flow direction is from top to bottom, you can install it too. Why? Because we just want to keep the cross section of the pipe full all the time. So if it's just semi-full and it's not full completely, for sure it has an error on the measurement. And as you know that it's just it's the only case that the liquid can just fool the all cross section of the pipe, is just the time that it flows and streams from bottom to top. Another one is the venturi, just presented before. You can find in the line that there are two taps here, and these two taps that they are always half of the inches would be connected to the pressure transmitter, I mean differential pressure transmitter, via tubes, I mean stainless steel tubes. And after that, the differential pressure transmitter will measure the differential pressure from these 2 points. And finally, it can be converted to flow and send it to control room, for example, with the help of 4 to 20 milliampere signal. Another one is the orifice. You can find this orifice that these two flanges will be supplied with the orifice too. It's really important to know that the direction of the fluid is really important for the orifice. Because sometimes we try to change the shape of the orifice into the venturi. So in this case, the downstream of orifice would be in this of beveled form. I mean the bore here is not the cylindrical, but in this case we can find the beveled form in the downstream of the orifice. So in this regard, it's very important that how you install it. So sometimes, some of the engineers and technicians believe that, okay, it's just a simple plate. So there's no difference whether we just, install it in this case or this. No difference here. No, actually, it has a difference. As I mentioned, downstream of the bore is in beveled form. So that's why it's so important how you install it. So please bear in mind that in this case, we have a notification and we have a point or how can I say that, attending or caution on the handle of the orifice, and it shows that how the flow will streams into the bore. So another one, as you can see that here, there is an orifice with the two tubes that I mentioned. The stainless tube would be just connected to the differential pressure transmitter, and as you know that the differential pressure transmitter will always have a 5-way manifold as an accessory of it. Another one, we have the restriction orifice too. As I mentioned before, with the help of the orifice, we can make differential pressure in the pipe. Sometimes we just want to form this differential pressure in the pipe. I want to tell you that in this regard, it's not the form or it's not the principle of measuring. We just use or we just install the orifice in the pipe to just make differential pressure, and always it is it can be applied by process department engineers. Another restriction orifice that is uses for making the differential pressure in the pipe too. Another one, we just want to talk about the velocity, the velocity principle that is used and applied for measuring the flow inside of the pipe. So as you can see that there are different ways, but some of them would be, presented for you here. The first one is the turbine flow meter. For sure, actually, turbine flow meter can be used for case of the gas and the liquids, but it's not used for case of vapor and steam. Why? Because on the blades you can find the magnet pole. So that's why when it's installed in the fluid with high temperature, unfortunately the magnetic pole will be affected by high temperature, and unfortunately there will be an error for that. I just want to tell you that the maximum temperature that you can use for turbines around 140 degrees. It's the maximum that can be used. And another one is the magnetic one. For sure the magnetic ones actually can be applied for even the bigger size too. Now it's around maybe 96 inches that you can find in industry. Later I will just show you some more videos about myself that beside me there is an 48 inches of the magnetic flow meter too. But please have this item in your mind too, that the magnetic flow meter is just used for the liquids. This flow meter cannot be used for case of gas or even steam and vapor. So maybe there's a question for you. Why? Because magnetic flow meter works based on the conductivity factor of the fluid, and it must be at least 5 microsiemens per centimeter to be measured. So as you know that the gas or air or even vapor are not conductive. That's why they cannot be used. Or even magnetic cannot be used for pure water, for example. Demineralized water cannot be used because even the demineralized water or the pure water is not the conductive too. Another one is the target meter. It's the rare flow meter is used in the industry. I just want to tell you it's seldom applied, but it can be used for a case of measuring flow in the canal, I mean open canal. So based on the force that applies, on the disc, it can be, measured too. Another one is the ultrasonic, one of the most important, instruments that we apply. I just want to tell you that even the ultrasonic can be used for case of liquids and, gas. And with the number of sensors that you apply in this device, the how can I say that, the accuracy of the device will be, really less. It's around maybe, for example, 0.2%, which is really great for measuring the flow. So I just want to, summarize some points here. Process data is so important for measuring the flow because as I just, draw an example for you, sometimes when the flow is not conductive, you cannot, for example, apply one flow meter. But when the temperature goes up, maybe you have to forget some more flow meters. So this one is so important. You need to consider some things about the process data at first, and after you decide which one would be useful and practical for you in that case. For example, for case of ultrasound, bear in mind that when the bubbles form in liquid, when the bubbles form in fluid, unfortunately, the ultrasonic accuracy will be affected badly. I mean, awfully, it can be affected. Sometimes, you can find some, amounts on the display of the flow meter, but you cannot be sure whether it's correct. Another point that ultrasonic it cannot be used even for case of two-phase fluid. Sometimes that we have not only liquid, but also we have some vapors or steam in the line too. So in this case, we cannot measure that fluid by ultrasonic. Another one is the vortex flow meter. It has been just manufactured by some manufacturers in the world up to 12 inches too. For sure, actually, it's one of the most applicable and nice device for measuring the flow. It has its own limitation, as I mentioned before. When the Reynolds number comes down, the accuracy of the device will be dramatically, affected. Sometimes, actually, when the Reynolds number is less than 10,000, even, this device cannot measure the flow too. But I want to tell you that it can be applied for a case of high pressure and even high temperature. Moreover, when the particles or even debris can be found in the fluid, even the vortex flow meter can measure the fluid. So I just want to tell you that as compared to, for example, some other items, just like, for example, turbine or even the magnetic that I just mentioned, this device has less limitation. So you can find, the vortex flow meter here. And for sure, I just want to, draw your attention to something too. As you can see, there's a tube here on the vortex, which is related to the pressure sensor of the device. As I mentioned before, sometimes you need to convert the flow from the volumetric form to the mass form. So in this regard, at first, you need to calculate the pressure and temperature. And after that, you need to multiply the corrected or the compensated form of the density to the volumetric flow, and finally changes to flow based on the mass. So as you can see, this device is the compact form. So, and it means that it already has its own, pressure sensor, and it is calculated by itself. To tell you the truth, in this regard, there is no need to have the flow computer. So another one is a magnetic one. I just, put this picture for you to show that even you can install the flow meters based on the velocity on the vertical line too. So it's clear that it has been just, performed and it has been installed. Another one is the ultrasonic. This ultrasonic is based on the transit time. I mean, at first, the wave, the ultrasound, sends from the sensor to this part, and finally another one. There is another wave from this part this item. As you can see that in this regard, we will have a V form. That's why it is called as V configuration, or sometimes it's called as two traverse. With the help of this installation, which is called as the clamp on, there is no need for you to just put the sensors under the exposure of the fluid. As you can see that there's no wetted part here. I mean, there is no contact with the sensor and fluid. So that's why it can be used even for some cases, which is, for example, maybe the fluid is corrosive or things just like that. With the help of this type of installation, even you can install it on the bigger sizes of the pipe. For example, up to 160 inches can be applied in this regard, and you can install on the pipe without any problems. Some more things with that related for the fluid force, and the best example in this regard is for rotometer. Variable area flow is one of the most famous one. Unfortunately, one of the disadvantages of this device is that they are just manufactured in less sizes, around just 4 inches. But hopefully they can just use for many fluids, many type of fluids. You can just apply it for case of liquids, or even for sometimes that fluid is in erosion form or even corrosion form. Sometimes that maybe you can find some particles or debris in the pipe. You can just have this flow meter for measuring. Unfortunately, they do not have good accuracy. It can be considered around 2%. But in chemical industry or in utility, or even the packages, you can just find it, because in this regard, or in these cases, we have small sizes of the pipes. For example, just corrosion inhibitor package, or even, for example, for fuel gas, for example, package. You can just find it in the pipe too. Just some more things related for measuring flow based on the mass. Up to now, we've just talked about a lot of instruments for case of measuring of the flow, and all of them worked based on volumetric measurement. Now, we want to talk about some devices or some instrument that they measure the flow based on the mass. In this regard, there is no need for you to compensate the volumetric flow. As I just, have a feedback to my previous words, at first, we just used to calculate the flow based on the volumetric. After that, multiplied into density. And finally, we had the flow based on the mass. But these devices itself, actually, or themselves, just calculate the flow based on the mass. That's why these devices can be categorized into the best type of the flow meters. Unfortunately, they're very expensive, and you must know that where you want to install. For example, you cannot just use them for measuring the, for example, I don't know, the water which is drains from a vessel to, for example, closed drain. But sometimes they can just be used for a case of exporting the fluid from one point to another one, because in this regard, that financial matters must be taken into consideration. So another thing that I just want to tell you about the Reynolds is that this device, it can be measured the density too. So even you can just apply this one for measuring the flow. Sometimes you can just have it for measuring the density. So that's why it's one of the most beneficial, one of the most and high-tech flow meters. But I want to just mention this item that unfortunately, this device has been just sized or has been manufactured in small sizes. As a routine size, the bigger one is 6 inches, but sometimes it can be manufactured up to 12 inches too. But in this regard, the device will be sized and will be manufactured optionally. Maybe for finding a Coriolis with 12 inches, you need to just be waiting for around maybe 6 or even 7 months to be delivered. But as I mentioned, that the routine size of it is just 6 inches. For sure, it has a really good accuracy, and even it can be used for different cases too. For example, for liquid, and even, for example, for case of a fluid, and the other thing can be applied. Okay, so, and there's just one more thing that I just want to say that, and it's about that PD meter, which is called as the positive displacement. As you can see that here, it would be called as positive displacement. Because we just talked about different things such as the high temperature, pressure, and temperature, and even we talked about composition of the fluid, which can be included particles and debris and stuff like that. But I have not talked about the high viscose fluids yet. Sometimes the fluid is in high viscosity, for example, tar or glue or even honey, which can be, measured in different industries. One of the most applicable and famous device for measuring this item is the PD one. I mean, the positive displacements. So this device can be just measured the liquids. I mean, just liquids. So please have this one. It cannot be used for case of gas or the vapors. And the size, sometimes it can be from 1/4 inches up to, for example, around 40 or even 60 inches. In this photo, you can just find the positive displacement in 60 inches. If you just compare these technicians with the device, you can find out how much big it is. And some more things about this item. I just want to get back to the file. I just want to show you that there are just some points that you need to bear in mind about the flow. And I just mentioned this one as the notification of this one. The fluid and state so important to find the best one. I just made an examples for some cases, such as, for example, magnetic and stuff like that. I just mentioned about the accuracy too. Some cases, such as, for example, orifice does not have a good accuracy, but sometimes you have Coriolis with the best accuracy among all of them. Flow compensation is so important. Sometimes you need to just install a pressure or temperature beside the flow meter to find out the mass. I mean the flow of based on the mass. And sometimes maybe you just apply some flow meters which are compacts. I mean, they themselves have the pressure or even temperature sensors with them, and they can just give you the flow based on the mass. Reynolds number is so important. You find out that it has a really big effect on the measuring of the flow. Then we have the upstream and downstream. It's so important, and you need to bear this one in your mind. What it is exactly, we need to keep the line straight from one point to the flow element. How? Just imagine this is a line, and this is the flow element here, and this one is a thing that you can see. Okay, and this one is the upstream. This one is downstream. And you can just see this one that when, for example, we have an elbow here, the pipe, you can just find out that, from the elbow to the flow element, we need to keep the pipeline straight. Why? Because the profile of the fluid here must be in case of laminar or linear. Otherwise, the fluid will be turbulent and it will have a really bad effect on the flow element. Sometimes that you find out the measure, the measured flow on the display, but it's not true. So this length, this S-straight length must be kept. This length actually is completely different among, the flow meters. Some of them have a really long or need actually long straight line or straight run, but some of them have, really short straight run. For example, when we are talking about the orifice, sometimes, this straight line for can be from 6D. When I'm saying D, it's the, let me just, write this one for you. It's just the upstream. For the orifice, it can be from 6D, it's the diameter of the pipe, up to, for example, 50D. Just imagine, for example, when you have an elbow, maybe, for example, you have around 20D for case of upstream. In this regard, if the line size is 3 inches, you need to multiply 3 inches into, for example, 20, and it reaches to 60 inches. It means that 60 inches from this point, from the elbow to the flow element, it must be straight, and you must not put any other devices in this straight form or straight run. And then we have the downstream. And when I'm talking about the downstream, it's the length that we need to change the turbulency of the fluid that formed when, it gets out from the flow element. And, after that, it becomes calm. It becomes laminar. So it can be around 5D to 7D for the orifice. So this one is downstream. So it means that after 5D of the flow element, the profile of the fluid become actually laminar or linear. So it's an example for the orifice. I just want to tell you that even for correlates, we are talking about the PD meter, positive displacement. Or when we are talking about the rotometer, there is no upstream or downstream, and they do not be considered. So this one is so important, and you need to check the upstream and the downstream of the flow element, because in this regard, you have an interface between the piping department, because as you know that all these flow elements will be modeled and will be designed in the 3D model of the piping too. And I just want to tell you that for the last items, for a case of range and turned on range, I mentioned before, it's so important because, amount of the flow must be placed in the range of the measuring of the flow meters. And finally, we talked about the installation, that you can have this opportunity to install the flow meter in the vertical lines too. I just want to show you that some more things about items to clarify some things too. So let's just put this one. I just, said something about a magnetic form. I just want to show you that even for case of the magnetic, you can just, for example, see this one here. As you can see in this movie, as you can see that in this movie, it's a 48 inches of the magnetic. And it shows that, one of the most important things that you can find in this movie, that it does not have any wetted part, and it does not have any differential pressure in the line. So another thing about the upstream and downstream of the flow meter, the magnetic flow meter, is that it's really less. 5D for upstream and just 2D for downstream will be sufficient. Okay, so that's it. And sure. And now we just want to talk about, some Christians that